After measures of central tendency in section 7.2, the text then moves on to the idea of measures of variability. The word variability and the mathematical concept behind that word is how spread out or how dispersed is a set of data. What is the spread of the data? This is going to be very, very important for what we're going to do in section 7.3 when we talk about data distribution. So it's important that you have a good understanding of the concept of variability. Under the concept of variability, we're going to talk about three different measures. Range, number 1, and then mean and standard deviation, number 2 and 3. Mean deviation and standard deviation are just different measures that are kind of saying the same thing. Mean deviation is a little bit simpler and standard deviation is a little bit more complex. But let's start with the range. The range is by far the easiest to understand, and it's very easy to understand. The range is very simply the difference between the smallest and largest data point. So if I create a set of data here, let's say starting at 2, 4, 6, let's say I have a whole bunch more data points here, all the way up to 104 is my largest point. The range is the difference, meaning subtract, between the largest and the data point, largest and smallest data points. So the range, in this case, is the number 102. The data ranges from 2 to 104, which is a distance of 102 units. Okay, and that's always how we can find the range. The problem with stopping at the range is two data sets can have the same range and still be organized very differently. Let's take a look visually with a couple of graphs at what that might look like. They have an example of this in the book, which is a really good example. I really like it. Okay, so I'm going to give you a couple of different graphs here. So let's say this is 1, 2, 3, and 4. And let's say this is the numbers 2, 4, 6, 8, and 10. And then let's do another graph here. Okay, so these are two histogram type graphs where, just to give you a brief background for understanding how to read these, the way you would read this is that the value 2 occurs one time. So if I were to actually write out this data similar to the way that I wrote this, it would look like this. So hopefully this will help you connect. I would have 2 one time, I would have the data point 4 twice, so 4 and 4. 6 4 times, so 1, 2, 3, 4, 2 8s, and then 1 10. When I read it that way, you can see pretty quickly that the range in that set of data is 8. 10 minus 2 is 8, so the range here is 8. Now, the interesting thing is, if I were to repeat that with this data set, which obviously this graph looks a lot different from this. It's spread out a lot different. This kind of builds towards the middle. This has what we'll call in section 0.3 kind of a normal distribution, a bell-shaped curve distribution, where this is very different from that. It's almost like a U distribution, where there's no data points in the middle, and then the extreme left and right are up pretty high. But the range here is still 8, because the smallest data point is 2 and the largest data point is 10. So the range, if all we have is the range to go by, the range of these two data points is the exact same, but they look very different. The reason that I bring this up is because that's the case, we need some more sophisticated measures to talk about how data is spread out, so that we don't just have to rely on the range. If all we have is the range, these two things would be the exact same, but obviously they look different. So now we're going to take a second and talk about mean deviation and standard deviation. I want you to pause the video here for a second and go ahead and get your textbook. And I'm going to follow very closely an example from the text on page 448. This is figure 7.25 on page 448, talking about mean deviation. The idea of mean deviation is this. I'll go ahead and write it out for you. The mean deviation is the average distance away from the mean of a data point. I'm going to do another computer video where I show you how to calculate the standard deviation of a set of data using the Desmos online graphing calculator. How to actually calculate it is pretty tedious, meaning it takes a long time and it's very rigid. There's a lot of steps, a lot of calculations. So I would actually much prefer that you use a graphing calculator or online calculator to calculate this for you, but I do expect you to know how to do that. So let's take a look at page 448 in the book. They give us a set of data here, and the set that they give us is 1, 2, 3, 3, 3. Let me see how many threes they have there. It looks like there are 6 threes, and then 4, and then 5. They tell us that the mean, which just as a side note, oftentimes mathematically, when you see an X with a line over it, we call that X bar, which is a mathematical symbol for the mean. They tell us that the mean is equal to 3. The mean deviation, the way that we calculate that is we take each of our data points and we find out the distance that each of them are from the mean. So here's our data, and here's our distance from mean. I'm not going to go through this whole process because it would make the video too long. I'm going to go through a couple of steps and then hopefully you'll be able to follow from there. So if I take my first data point is 1, and the distance from the mean, 1 minus 3, so this is my data point minus the mean. The distance from the mean is, well, this is -2, but since it's a distance, we're always just going to put it as a positive, so 2. Probably the easier way to do that would just be to reverse that subtraction. And then I'm going to continue that for each of my data points. So 2 minus 3, that's 1 away from the mean. All of these 3's are just going to be 0 away from the mean, so on and so forth. Then what they're going to do, if you take a look at the green table on page 448, is they're going to take all of these distances from the mean and they're going to add them up and average them. So they're going to take the mean, or the mathematical average of all of these numbers, and that mean of all of these actually ends up being 0.6, and 0.6 is the mean deviation. There is a similar but more complicated and longer calculation for standard deviation. But instead of taking you through that, again, I'm going to do a computer video of how to calculate the standard deviation. I want to take a couple of seconds to talk about the mean and standard deviation and how you interpret that. Okay, so let me do that real quick here. There's really just 2 things I want you to know about mean and standard deviation in terms of how, because if you just have the number, if you just have the mean or standard deviation but you don't know how to interpret it to you, then it's pretty much useless and our time in this section is wasted. You need to know something about it. So here's what I want you to know about it. This is both for mean and for standard deviation. I'm going to abbreviate DEV for deviation. The larger the deviation, the more spread the data is. Okay? The mean deviation and standard deviation, what those numbers are telling us is on average how far away is each data point from the mean. So in our last example, when we got 0.6, that's a pretty small number. It's less than 1. Why is that? Well, the mean in our last example was 3, and we had a bunch of data points, if you remember 6 of them, that were 3. The distance that each of those is from the mean is 0, and the other numbers that were not 3 were actually still pretty close to 3. So if I take the average distance away from 3 of all of these numbers, when I include the other numbers in the data set, that's where I got the 0.6. But the larger that the deviation is, what that means for the data is more spread out. So let me give you an example of a type of homework problem that you may have. All right, here are two different sets of data. One of the things that I could do to test whether you understand this concept of deviation, mean deviation or standard deviation, is to ask you the following question. Just by looking at these two sets of data, which do you expect would have the larger, I'll use standard deviation, but they both basically mean the same thing. Which would you expect would have the larger standard deviation? So think about that for a second and answer that in your own head. The answer to that question is by far that this first set, we'll call it A, this first set would by far have the larger standard deviation. Why is that? Well, when you look at this data is really far, relatively speaking, spread out. It ranges from 1 all the way up to 80. We have some small values, we have some kind of intermediate values, and then we have a really big value of 80. In terms of how the data is spread, it's very spread out. The fact that these numbers are much larger than these numbers has nothing to do with the deviation. The deviation is only concerned with how far they spread apart. So these are only spread from 123 to 132, the range is much smaller, and the values in here are clustered much closer together. So if we calculated the deviation of set B and compared it to the deviation of set A would have a much bigger deviation, a much bigger spread than set B. However, if you were to talk about the mean, the average, set B would have a much larger mean because these numbers are a lot larger. So you see how it's important that you understand the difference between things like mean, median, and mode, and range and standard deviation. Another point that's going to become very important in section 7.3, having to do with the standard deviation, is found at the very end of section 7.2. And I just want to draw a graph for you. And I want to talk about how to read this graph, because one of the things that happens in this course is there's a lot of symbols that are being used that you're probably not real comfortable with, and a lot of times that can be difficult and scary, and even though it's things that mathematically are not that hard, if you don't understand the symbols, it can make the problems a lot harder for you. So let's say that we've done a problem and we've identified in our data set that the mean, the mathematical average, which we call x bar, is 20, and the standard deviation, which, and this is a new thing, the Greek letter we use for standard deviation is this O with kind of a tail coming off the side of it. We call this a sigma. It's a Greek character. The sigma is 2. So on average, a data point is 2 away from the mean. One of the very common things that we'll start doing in section 7.3 is we'll split up our data into segments where the length of the segment is 1 standard deviation. Okay, so see if you can follow me on this. I think that you'll be able to. If the mean is 20 That means this this average point of my data is 20. One standard deviation above the mean plus one standard deviation would be my mean 20, plus one of these would be 22. One standard deviation below the mean would be 20 minus one standard deviation, or 18. Two standard deviations below the mean would be 16, and two standard deviations above the mean would be 24. It tells us in our book, a really important point, that 75% of all the data in any data set will always be within two standard deviations of the mean. So what does it mean to say within two standard deviations of the mean? Well, in this example, it would mean between the numbers 16 and 24. So I just wanted to give you a little preview of what you're going to start to see in section 7.3 when on the number lines they start referring to these symbols with the mean and standard deviation and splitting up the number line according to these values of mean and standard deviation. So hopefully that'll be helpful on some of the homework problems. As always, let me know if you have some additional questions. I will do an additional short video that actually shows you how to calculate the standard deviation. I know I didn't do that in this video, so you can follow the book and that's helpful, but also look for the computer video.